In this video, we will learn to solve an inclined determinate structure. The inclined structures are more complex than the normal structures to solve. Therefore, we are going to learn to solve an inclined structure which is subjected to several loads, in a very easy method. In our problem, we have a horizontal beam BC, where at end C there is a pin support or simple support. At the end B, an inclined link was attached using a pin joint. At the other end of the link, it was supported with a simple support again. The vertical height of the inclined support is 4 feet. And the horizontal distance has been divided into 4 parts. From A to B, it is 3 feet, and the second and third part is also 3 feet. And finally the fourth part of the horizontal distance is 4 feet. There is a clockwise rotation of magnitude 20 kips-feet is acting at a distance of 3 feet from B. And at the end of the beam there is a uniformly distributed load of 9 kips per feet is acting for 4 feet distance. So, this is our structure. We are going to find the vertical and horizontal reactions in the support A and C, and the resultant force developed on the link AB. We will begin to solve the problem by drawing a free body diagram of the given structure. For the beam BC, there is a simple support at C, therefore, mark the vertical and the horizontal reaction at point C. Then there is an applied load of 9 kips per feet UDL is acting vertically downward. There is also an applied moment of magnitude 20 kips-feet is acting in the clockwise direction, on the beam BC. And finally, at point B, there is a link attached with a pin support in the inclined manner, therefore, support B has to create a reaction in the same axis of the inclined member, which is nothing but the resultant reaction of that link. This resultant reaction can then be resolved into vertical and horizontal components. Let's say the angle made by the resultant force to horizontal axis is theta. So, this is our free body diagram for the horizontal beam BC. We will next draw a free body diagram for the link AB. Here, we know that the link will be subjected to the reaction of the resultant force in the opposite direction at point B. And at point A, there will be a reaction of same resultant force acting in the opposite direction, to keep the structure in stable or equilibrium condition. In addition to this, there is a simple support at point A, which is going to develop a vertical and horizontal reaction. As per the rule of alternate angles, the angle between the link and the horizontal axis is going to be theta again. Now, we can write the equation for AY and AX. That is, AY is equal to r sine theta, and AX will be equal to r cos theta. This will give us the free body diagram for the link AB. We can find theta from the given structure using simple trigonometry formula. The vertical height of the link is 4 feet and the horizontal distance is 3 feet. Therefore, theta is equal to tan inverse of 4 by 3. Which on simplifying we will get theta is equal to 53.13 degree. Let's now begin to determine the reactions on the support C and the resultant force on the joint B. Considering the beam BC, let's use one of the equilibrium equation, that is summation of forces in the x direction is equal to 0. On seeing the free body diagram of beam BC, it is evident that only two forces are acting in the x direction. that is the reaction Cx towards right and the horizontal component of the resultant force R cos theta towards left. Therefore the equation will be, Cx minus R cos theta is equal to 0. And, Cx is equal to R cos theta. We will name this equation as 1. Then, we will use our next equilibrium equation, that is summation of moments about the support C is equal to 0, since it is pin support. On seeing the free body diagram of a beam, we can say that the vertical component of the resultant force is creating a counterclockwise moment towards support C, and there is an applied clockwise moment of 20 kps, and an uniformly distributed load of 9 kps, which is creating a counterclockwise rotation towards support C. Well, now keep the counterclockwise moments as negative and clockwise moments as positive, and write the equation. We will be getting, minus R sine theta times 10 feet plus 20 minus 9 times 4 by 2 is equal to 0. On simplifying the equation, we will get the resultant force on the link R is equal to minus 6.5 kips. Since the resultant force that determined is negative, the correct direction of the resultant force is opposite to the assumed direction. That is, the assumed direction indicates the resultant force is of tensile nature, to point B, but actually it is compressive, to the point B. Well, we have just found the resultant force that can be possibly act on the link AB. Now, we can substitute the resultant force value and theta value in the equation 1, to determine the horizontal reaction of the simple support at C. So, on simplifying the equation, the horizontal reaction at support C is determined as minus 3.9 kips. Which also says, that the direction assumed is incorrect, therefore the direction of the horizontal reaction should be opposite to the assumed direction. Let's now use our third equilibrium equation, that is summation of forces in the y direction is equal to 0 on the beam BC. We can see that there are 3 forces acting in the y direction on the beam. That is reaction Cy in the upward direction, R sine theta in the downward direction, and 9 kps UDL in the downward direction. Assuming upward forces as positive and downward forces as negative. Write the equation, we will get Cy minus R sine theta minus 9 times 4 is equal to 0. From which, we can substitute the value of R, that we have found already, and get the value for reaction Cy. Which is equal to 30.8 kips. Since the answer is in positive value, the assumed direction of the reaction Cy is correct. Next, we will use the free body diagram of the link AB, to find the reactions on the simple support at A. While drawing the free body diagram, substitute the value for resultant force R. And, we already know that, AX is equal to R cos theta. By substituting the values of R and theta, we will get AX is equal to minus 3.9 kips. Again, the direction must be changed in the opposite side. Finally, we know that AY is equal to r sine theta. Substituting the values of r and theta, we will get AY is equal minus 5.20 kips. Henceforth, we have found all the unknown reactions on the support A and C and the resultant force on the link AB. For more video lectures on civil engineering and the solutions for the unsolved problems with explanation, do subscribe to this channel Civil Engineering Geeks and press the bell icon for instant notification whenever there is new video upload on this channel. Thanks a lot.